This is going to be a review for your quiz tomorrow. Your quiz is over factoring. Please remember, if you want to use a calculator on tomorrow's quiz, you have to bring a calculator. Okay? I will not let you use cell phones or iPods or iPads or anything like that. Okay? You've got to bring your own calculator. All right. So just to start the review, let's go ahead and just take a look at number 1. I just want to work a couple of problems with you. Make sure everybody remembers what we're doing here. Okay? And number 1, we have 4 terms. The first step, anytime we have any polynomial, is to look for the GCF. Do we have one here? No. Nothing can come out of all 4 terms. So we then go into the next step, which is what? Grouping. Yep. Take the first 2, group those together. Oops. And take the second 2 and group those together. All right, so looking at just the first group, what can we factor out? 5x squared. What's left behind? 5x plus 3. Okay, second group, what can we factor out? 4. Leaving us with 5x plus 3. Okay, and now we can pull out that common factor of 5x plus 3. So we have 5x plus 3 times what's left behind, 5x squared plus 4. Okay? And that's it. That's all there is to it. So, since this is your review, I want you guys to glance over this worksheet. There is a front and a back. Glance over this worksheet. I want to work some of these problems with you, but I want to work problems that you want to see. Okay? So as you look through this, which ones look confusing that you want to maybe see worked out? Yes, sir. Hand was up. Please. 5. Okay. Working number 5. All right. The first thing in working this problem is deciding if we have a GCF. Now, in this one, this should be fairly quick, because if you look at the 8 and the 3 at the end, look at the small numbers, all right? The small numbers, no, there's nothing that goes into 8 and 3, so therefore there is no GCF for this guy, which means we immediately go into grouping. All right, just like our last problem we did. So now we've got to look at 64k cubed minus 24k squared. What can be factored out of both? 8k squared. Oops. 8k squared. And what do we have left inside? Oops. 8k minus 3. All right. Okay, second group. Can we factor anything out? No, but what do we then pull out as kind of a placeholder? A 1, right. So plus 1 times 8k minus 3. All right, so we can now factor out the 8k minus 3 binomial, which leaves us with 8k squared plus 1. Okay, any questions on that? Anything else you'd like to see? Number 10? Sure. Okay, looking at number 10. Now, first thing that I see in number 10 is that first term, the negative 5b squared, is negative. So we at least need to pull out a negative 1. But is there anything else we can factor out of that? Negative 5 is what we're factoring out, exactly. So, negative 5 times what's then left behind? Positive b squared. Anything else? 9. Positive 9b. And if we factor out a negative 5 from negative 90, 18. Positive 18. Okay. So, we have this now. In that trinomial, we need to multiply our a and our c. So we're going to draw our x off to the side. A times c is 1 times 18. B is 9. So we need two numbers that when we multiply them together give us 18, but when we add them give us 9. 6 and 3. Excellent. So we rewrite. B squared plus 6b plus 3b plus 18. Okay, and now it's a matter of going through the grouping process. Our first group, we can factor out a b. Gives us b plus 6. Our second group, we can factor out what? A 3. Leaves us with b plus 6. So we have negative 5 times b plus 6 times b plus 3. See if I can write that a little neater for you. Slightly better. All right. There we go. There's number 10. Anything else? Again, look at the back. There's more problems there as well. 17. All right, number 7. Okay, number 7 is actually pretty straightforward. Sometimes the easy ones are hardest to see. Okay, just go through the steps though. Always think through the steps. Step 1, anytime you're factoring a polynomial, is there a GCF you can factor out of everything? Okay, what are we factoring out here? N. Leaves us with n plus 3. Okay, second thing, can you factor n plus 3? No, it's not a difference of 2 squares. There's nothing else we can factor out of it, and so that's it, we're done. Yeah, easy peasy. Okay? All right. Okay. Taking a look at number 17. Again, yeah, we can pull out a negative 1, right? Is there anything else we can pull out with the negative 1? No, there's not. Just negative 1. So, negative 1 times 6v squared minus 59v minus 10. Okay, so we now need to go through and do the x method like we've always done. We take 6 times negative 10, negative 60, negative 59 is what we're looking for. Okay, two numbers that when we multiply them give us negative 60, but when we add them give us negative 59. That's exactly it. Negative 60 and 1. Negative 60 and 1. So we need to break apart that middle term. Negative 1 times 6v squared minus 60v plus 1v minus 10. And now it's a matter of going through the grouping process again. Please make sure you're always putting a plus sign between your two groups. Okay? If it's a minus right there, then we have to say plus a negative, whatever that third term is. You got to rewrite it so it's plus there. All right, -1, the first group, we're factoring out what? 6v, which leaves us with v minus 10. Second group, what are we factoring out? 1, yeah, there's nothing else other than a 1 for that placeholder. So we have v minus 10 there. And so then v minus 10 is our common factor we want out now. And we have 6v plus 1. All right, good work. Anything else? Yeah. I'm sorry, say it again. 7.